Hello everyone, welcome back. I am continuing 6.7. Now you can see my calculator. So the first thing we need to do is we need to make sure our calculator is in degrees. So to do that, we're going to do mode, which is next to the second button. And you want to arrow down to the third line where it says degree and radian. You're going to arrow over to degree and hit enter. Then we need to get out of mode. So we do second, quit. Now what we can see is that our calculator above our parentheses and our comma have a sine, cosine, and tangent button. So if we do sine of 35, you can see that that's a long decimal. What that is our calculator has memorized a table. So when I have a triangle with the 35-degree angle, the sine is always going to equal that. If I do cosine of 35, I also get a number, and tangent of 35, I get a number. So when I know the angle, I can find the missing sides by using my sine, cosine, and tangent, because those are just numbers. So now I want to find the missing sides. So I'm going to choose angle A, because that's the angle I know the measurement of. C is my right angle, which means 7 is my hypotenuse. So BC is my opposite, which I'm going to call X, and AC is my adjacent, which I'm going to call Y, because I need to find X and Y. So to find X, X is my opposite side, and I know my hypotenuse. So the ratio that uses opposite and hypotenuse is sine. So I'm going to say the sine of 35, because that's my angle measure, equals X over H, because sine is opposite over hypotenuse. Now, I don't want to write out that long number that my calculator told me. So instead of writing X over H, actually, I should have put X over 7. So I'm going to multiply both sides by 7. And so it's 7 sine of 35 equals X. And let's round to the nearest tenth. So I can find that on my calculator by doing 7 times, 7 times the sine 35, close the parentheses, and that means X is 4.0. It's actually 200th, 4.01. Now I'm going to find Y. So to find Y, that's the adjacent side. So cosine of A is the adjacent over hypotenuse. So the cosine of 35 is Y over 7. Again, I'm going to multiply both sides by 7. And so Y equals, now I'm going to do 7 times cosine of 35. 7 times cosine 35, and it's 5.73. And that's how you find a missing side. Now, we can also tell our calculator to read that table I said it has memorized backwards. And that's what we're going to need to do when we're finding a missing angle. So here we want to find the angle X. So here's X. So we label our parts. So 15 is our hypotenuse. This is our opposite, and 6 is our adjacent. So looking at our triangle, we're going to see what ones do I know. I know the adjacent and the hypotenuse. So what ratio uses that? Well, that's cosine. So cosine of X is equal to adjacent over hypotenuse. So cosine of X equals 6 over 15. but we want to find x. So how we separate that is we do the inverse cosine. So cosine to the -1 of 6 over 15 equals x. So how we get our calculator to do the inverse is, see how it's above it in blue? We do second cosine, and then 6 divided by 15, goes it. And we're rounding to the nearest degree, so it's 66 degrees. So here are two examples where you're going to find the missing side. So again, we want to find both missing sides, so I'm going to call this one x and this one y. So we know angle z. So knowing angle z, I do the other sides in ratio in respect to angle z. So in respect to angle z, x is across from it, so it's our opposite. Across from the right angle is always your hypotenuse, and y is next to z, so that's our adjacent. So to find x, that's opposite over hypotenuse, so that's sine of 39 equals opposite over hypotenuse. So sine of 39 equals x over 7. We multiply both sides by 7, and x equals 7 times the sine of 39. And x is 4.41. Let's do the hundredth again. Now to find y, that's the adjacent and our hypotenuse. So I want to say the cosine of 39 is our adjacent over our hypotenuse. So the cosine of 39 is y over 7. We're going to multiply both sides by 7. And y is 5.44. So I want you to pause. I want you to try number 5 and come back. Okay, so I started set up number 5. So E is the angle we know. So that means 14s are opposite. ED, which I labeled X, is our adjacent. And our hypotenuse is Y. And our ratios are sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. So the sine of 24 is 14 over y. So I cross multiplied. I had y sine of 24 equals 14. Remember, the sine of 24 is just a number. So I divided both sides by the sine of 24. And do that on my calculator now. I'm going to use the fraction. So alpha y equals fraction 14, denominator, is sine of 24. And that tells me that y is 34.42, rounded to the 100th. Now I need to find x. So again, I have adjacent and opposite, so I want to use tangent. So I'm going to use tangent, because you should always use the side you're given. So the tangent of 24 is 14 over x. So again, I'm going to cross multiply. So that's x tangent of 24 equals 14. I'm then going to divide both sides by the tangent of 24 because that's just a number. And I do that on my calculator. Alpha y equals 14 over the tangent of 24. And to make that a decimal, I do alpha y equals option 4. It's 31.44. Okay. So 2 more problems, I believe, where we're finding the angles. Like all zoomed. Okay, so here I'm finding angle X. So if this is X, Y means 15 is the hypotenuse because it's across from the right angle. 6's are adjacent because it's next to X. So the ratio that uses adjacent and hypotenuse is cosine. So cosine of X equals 6 over 15. So to find X, we do the inverse cosine. So that's cosine -1 of 6 over 15. So that's second cosine, 6 divided by 15. And I get 66.4, so 66. Number 7. Here's X. There's the right angle, so that's 24 is the hypotenuse, 13 is opposite. The ratio that uses opposite and hypotenuse is sine of X equals 13 over 24. So I'm going to do the inverse sine. So that's sine -1 of 13 over 24. And that's 33, rounded to the nearest degree. And that's the end of our videos today. If you have any questions, please ask me in class.